Hi, my name is Billy Jackson, and I teach mathematics at North Shore Community College. This lesson is going to be on solving proportions. A proportion is a statement that says two fractions or ratios are equal. So look at this example we have right here. We have two fractions. One of them is 1/2, or 1/2, and the other one is the fraction 5/10. And some of you may have experience with these two fractions and already recognize that those two fractions are equal. So how can we show that these two fractions are equal? Well, one way you may be familiar with is to notice that in order to get from 2 to 10, you get there by multiplying by 5. And if you look at the top, you can also get from 1 to 5 by multiplying by 5. So there's a common factor that you can multiply the top and bottom by, and that's why those two fractions are equal. Now we're going to be looking at a little bit of a different way to see that these two fractions are equal, in a more proportional way of thinking, I guess. And that is that we're going to notice that if you multiply the two diagonals of this equation, so here we have one diagonal, and here we have another diagonal. You'll see if you multiply that first diagonal, 2 times 5, you get the number 10. And if you multiply the second diagonal, 1 times 10, you also get the number 10. So that's a very common way to verify if a statement like this is actually a proportion or not. What you do is you multiply the two diagonals and see if they equal the same number. Alright, so now let's talk about how to solve a proportion in an example like this, where we have one part of it missing. So in order to solve a proportion, what we're going to do is multiply the diagonals and solve for the missing variable. So here we have a proportion, 4/6 equals x/15. And we're going to try to find out what that missing variable x is. So the first step is just like we did in that last example, we're going to multiply our diagonals. Okay, so that first one I circled would give us 6 times x. And the second one would give us 4 times 15. Alright, so now let's simplify a little bit. 6 times x, we don't know what x is yet. So we're just going to keep that as 6 times x. And the right side, 4 times 15, we know is 60. Alright, so when you get to this part of the problem, what you're going to do is you're going to look at that number next to the x, next to your variable. And in this case, that's the number 6. And we're going to divide both sides of our equation by that number 6, which is next to our variable. Okay, and then the 6/6 is going to cancel out and leave us with just x, that missing variable we want to find. And on the right side, we have 60 divided by 6, which is 10. And so that would be the answer. That gives us the missing variable in our proportion. And let's plug that back in up here to see how that fits in. So we were given 4/6 equals x/15, and I'll replace that x with the 10 we just found. And keep 15 on the bottom. Okay? If you multiply the diagonals, you'll see 6 times 10 is 60, and 4 times 15 is 60. So that must mean that we got the correct answer. Alright, now let's dig a little bit deeper into this. We're going to solve a proportion, but first, we're actually going to use a proportion to help solve a problem. So in this example, we say a basketball player scored 8 points in 20 minutes of playing time. At this rate, how many points would he score if he had 48 minutes of playing time? So I'm going to use a proportion to help set this up. We're given an initial rate for this basketball player, that he scores 8 points per 20 minutes. Okay? You'll notice I wrote the point and the minutes there, and I think that's really important. So we're trying to find, at this rate, how many points would he score if he had 48 minutes of playing time. So the points is going to be, how many points is going to be our missing variable. And we know that there's 48 minutes. So, well, maybe we could set it up as x points over 48 minutes. That's a possibility. Or maybe we could set it up as x points on the bottom and 48 minutes on the top. Well, if we did these each way, we would definitely get a different answer each time. So which one is the correct way? That's going to be very important to us. And it turns out what you have to do is make sure that your units match up. So, for instance, you'll see right here, on top we have 8 points. So we want to make sure that points goes up top here on our second fraction. And on the bottom we have minutes, so we want to make sure that minutes goes on the bottom in our second fraction. Let me clear off these circles. Okay. So, the points, which we don't know, that's our unknown, our variable, is going to go up top. We're going to say x points, and the 48 minutes will go on the bottom. And that's a very key first step, just being able to set up the proportion correctly. All right, and now we can go through and solve it, just like we did our last examples. What we're going to do is we're going to multiply our diagonals. So the first one is 20 times x equals, we multiply our second diagonal, which is 48 times 8. Okay, and now we'll simplify. So on the left, well, we don't know what x is, so we can't simplify this yet. We just know it's going to be 20 times x. And then on the right, we have 48 times 8. I don't know what this is off the top of my head, so let me do a little scratch work. 48 times 8 is going to be, 8 times 8 is 64. Write the 4, carry the 6. 8 times 4 is 32, plus 6 is 38. Okay, good. So 48 times 8 is 384. All right. So I have 20 times x equals 384, and if I want to solve for my missing variable, the x, I'm going to divide both sides of this equation by that number next to the x, which is the 20. And then these cancel out, leaving me just with x, which I'll put down here. And x is going to equal 384 divided by 20, which I'm going to need to do a little scratch work to find out what that is. 384 divided by 20. So 20 goes into 38 one time, minus 20. That'll leave me with 18. Doesn't look like an 18, does it? There we go. A little better. And bring down the 4. 20 goes into 184 9 times. 9 times 20 is 180, which leaves me with 4. And I can add a decimal point and bring it down. Put that decimal point right up top of my quotient too. And 20 goes into 40 2 times. 2 times 20 is 40. And now I have no remainder. So that means that 384 divided by 20 is 19.2. All right, so that means that this player would score 19.2 points if he had 48 minutes of playing time. All right, great. All right, let's do one more example together. On a map, 1 inch represents 75 miles. So if two cities are 3.5 inches apart on a map, then how many miles apart are they in reality? So let's use a proportion to help us with this. So our first ratio says that 1 inch represents 75 miles. Okay, and then the next side, the next ratio, mentions these two cities that are 3.5 inches apart on a map. How many miles apart are they in reality? So the first part that we're given is the 3.5 inches on the map, and the next part is the how many miles are they in reality. So, like I said last time, what's very important is that our units match up. So, the 3.5 inches, should that go on top or bottom? Well, that would match up with our 1 inch on top. So, 3.5 inches should go up top. And how many miles, that's our missing variable, x miles, will go on bottom. All right, cool. So now we can go ahead and get started. We're going to start this by multiplying our diagonals, just like we did last time. 1 times x and 75 times 3.5. So 1 times x equals 75 times 3.5. I'm going to have to do some scratch work over here. 75 times 3.5. 5 times 5 is 25. 5 times 7 is 35. Plus 2 is 37. Now 5 times 3 is 15. Carry the 1. 3 times 7 is 21. Plus 1 is 22. So 5, 12. 1 plus 3 plus 2 is 6, and 2. And my decimal point would go 1 space in, so 262.5. So 75 times 3.5 is 262.5. All right, now we need to solve for x, our missing variable, and we always do that by dividing by the number next to the x, which is 1. And this is going to turn out to be pretty easy in this case, right? The 1's cancel, and you're just left with x equals 262.5 divided by 1, which is just 262.5. All right, cool. Now you try an example. Pause the video and try to solve this problem. And then when you press play again, I'll work through it, and you can see if your answer compares to mine. All right, so this problem says it took me 30 minutes to drive 20 miles to work today. So that is going to be my first ratio, 30 minutes to 20 miles. At that rate, how long would it take me to drive 30 miles to work? So how long is referring to minutes, and how long would it take me to drive 30 miles? So I have to make sure my units match up. My 30 miles is going to go on bottom to match up with my 20 miles down here. So I'll put 30 miles on the denominator over here. And how long, how many minutes, that's my missing variable. So I'm going to put up top x minutes. All right, and now we can go through and solve this proportion just like we had done before. We're going to multiply the diagonals. 20 times x equals 30 times 30, which turns out to be 900. Then we'll divide both sides by the number next to the x, which is the 20, and we get x equals 900 divided by 20. And let me do that out up here to find out what that answer is. So 20 goes into 90 4 times. Minus 80 is 10. Bring down the 0. 20 goes into 105 times. And now I have no remainder. So the answer would be 45. It would take me 45 minutes to drive 30 miles. All right, great. So keep practicing, and we'll see you again soon.